Alright, this video is going to review the first page front and back of your Part 1 semester exam review. Number 1, how many non-collinear points are required to name a plane? Remember, a plane is a flat surface. In order to name a plane, you need not 1, not 2, but 3 non-collinear points in order to name the plane. So if I knew this was point A, this was point B, and this was point C, I'd have plane ABC. Number 2, how many points are required to name a line? If I have a line and it doesn't have a little lowercase letter at the end of it, so I need to use points to name it, I need more than 1 point. That's not enough, but 2 points would be enough to name the plane. So I need 2 points to name the plane. If this was A and this was B, I could call this line AB. Number 3, given A is between Y and Z and YA is 2x plus 5, AZ is x and YZ is 20, find the value of x. So when I look at the information, the first thing I see is YA is 2x plus 5. So that's that piece right there. And AZ is x, it's already labeled for me on my picture. And YZ is 20. Y to Z is not labeled in my picture, but I can write that. It's 20. Now, what's something that's really important to notice in this problem is it says A is between the 2 points. It doesn't say it's exactly in the middle. So that means I can't set my 2x plus 5 and my x equal to each other because I don't know if they're equal. What I need to do is I need to add them together. If I add them together, that means they have to equal something. What do they equal? They equal the whole thing, which we said was 20. Okay? So now to solve this, what we're going to do is first look on each side and see if there's any like terms to combine. When I look on this side, I can see, yes, I've got my 2x and my x. So I'm going to put those two together and get 3x plus 5 equals 20. Okay, so then I don't have any more like terms. I'm going to start moving things from one side to the other. So I'm going to subtract 5 on both sides. And I end up with 3x equals 15. Divide by 3 on both sides, and x equals 5. Okay, number 4. Number 4 is very similar. Given A is between Y and Z, again, it says in between, right? So I don't know if it is right in the middle or not, okay? So YA is 6. Oops, they didn't mark that for me. YA is 6. AZ is 4x. That's already been marked here for me. And YZ is 30. So the whole thing is 30. So this time, my left side 6 plus my right side 4x. I'm going to be adding them together, and together they equal the whole thing 30. So again, the first thing I want to do is look to see if I have any like terms. I don't. 6 plus 4x, neither one of those is a like term. So there's nothing to combine on that side, and on the other side there's nothing to combine either. So then I'm going to start moving things back and forth. So I want to get x by itself. I'm going to subtract the 6 on both sides to get 4x equals 24. Divide by 4 on both sides. And x equals 6. But be very careful, because if you look at your problem, it's not asking me to find x. It's asking me to find AZ. So AZ is this piece right here, which is 4 times x. So AZ is 4 times x. AZ is 24. Which makes sense because 24 plus 6 gives me my 30. Number 5. Given M is a midpoint. Oh, look, I have a midpoint this time. Okay, so given M is a midpoint, if I sketch a picture, this time I know that I do indeed have a midpoint. So if I look at my middle. I do have a midpoint this time. So that means these two sides will be equal to each other. M is the midpoint of AB. M to A is 4x plus 2. M to B is 8x minus 3. M to B, 8x minus 3. So this time I do know that those two expressions are equal because of the word midpoint. So 4x plus 2 equals 8x minus 3. If I look at my problem, it says to write an equation that would allow me to find x. That has been done. This is my answer. I have written the equation. Okay, number 6. Just like the last one, y is a midpoint. So this time again, I do have a midpoint. So if I look at my picture, I can put my dot right in the middle, which means that I can come back and say midpoint means both of these sides are equal. The midpoint is y, and it's the midpoint of xz. X to y is 2x plus 7. And y to z is 3x minus 4. And write an equation that would allow me to find x. These two sides are equal. Here's my equation. Okay, that's number 6. Right. For number 7, you had the distance formula. I gave you a formula sheet, so you had that available to you, and you will have the distance formula. You'll have the same formula sheet available to you when you take the exam. So the first thing I need to do is label my points x1, y1, and x2, y2. Then what I'm going to do is I'm going to rewrite my formula, but everything that I have in light gray, I'm going to leave blank. Okay, so then I'm going to go through and I'm going to look at my blanks, and I can see this says x2. So when I come over here and I look at x2, I can see that x2 needs to be replaced with an 8. Okay, when I look at x1, x1 needs to be replaced with a negative 2. And I know there's already a minus sign there, but you have to write the second negative. Okay, then my next blank, y2, so I come look over here, y2 is 2. And then my final blank is y1, and when I look back over here, y1 is 3. Okay, so now what I can do if I want is I could change this to a plus sign, or I could leave it exactly like that because this is ready to go in my calculator. When I put number 7 in my calculator, I end up with a distance of 10.0499. Remember, we're rounding to 3 decimal places, so this 9 right here bumps the second 9, which bumps the 4, so my distance equals 10.05. Now be really careful because that is not the same as a distance of 10. So if you have multiple choice and one is 10 and one is left as a square root, for example, a square root of 101, make sure you select the right one. This is not the same thing as 10. Okay? Number 8. Number 8 is another problem that's just like the one we just did, where the first thing I want to do is I want to write my distance formula without the x's and y's. So that I can come back through and fill everything in. The first thing I need to do before I fill in is I'm going to have x1, y1, and x2, y2. So that I can come here and see that x2 needs to be replaced with a 5. x1 needs to be replaced with a 2. y2 gets replaced with 3. and y1 gets replaced with 8. There's no minus and negative, so I don't have to change anything to a positives. I can go straight into my calculator. When I do that again, I get a decimal, which is okay, which rounds to 5.831. Again, that's not the same as 9 or 6. It's not the same as 5. It's 5.831. Okay, let's look at 9. Number 9 wants to find the midpoints of AB if A is at negative 10, 2, and B is at 6, 6. There is a formula for that, but what I like to do that I find to be a little bit easier is I like to write my 2 points one over the other. So negative 10, 2, and then 6, 6. Notice I left a space for my midpoint. Okay, so then what I need to do on each side is I'm going to average my x's. Remember, you average them by adding them together. So negative 10 plus 6 is, negative 10 plus 6 is negative 4. And then since it's two numbers, we divide that by 2. Negative 4 divided by 2 is negative 2. Okay, so then I'm going to do the same thing for my y's. Okay, I'm going to average the y's. To average two numbers together, add them together, 2 plus 6, and then divide by 2. 8 divided by 2 is 4. So my midpoint is the point 2, negative 2, comma 4. Notice it's in parentheses, it has a comma. That is my midpoint, the point negative 2, 4. Number 10. Find the coordinates of the midpoint of CD if C is at 5, negative 3, and D is at negative 7, negative 9. So I'm going to do the same thing. I'm going to write C. I'm going to leave a space, and then I'm going to write D. Okay? And then I'm going to do the same thing I did before. I'm going to look at my x's, and I'm going to average them. Okay? So 5 plus a negative 7 is a negative 2, divided by 2 is a negative 1. Then I'm going to do the same thing with my y's. I'm going to average them together. So negative 3 plus a negative 9 is a negative 12. Divided in half gives me a negative 6. I put my comma in between, and here is my midpoint, the point negative 1, negative 6. Number 11. Number 11, I want to name 4 pairs of vertical angles. So when I look at this picture, remember vertical angles are angles that are across from each other. So A and C, B and D, that's a D, Q and S, and my last one, P and R. Okay, and then I want to name 4 linear pairs. So linear pairs, remember, are going to be like right next to each other, like A and B, or C and D, or Q and P, or R and S. Okay, but remember, they could also be next to each other this way, like Q and R. I know we only had to name 4, but Q and R, or P and S, or B and C, or A and D. So there's really 8 sets of linear pairs. Okay, so then the next question wants to know, erase that out. The next question wants to know, what is angle P congruent to? Okay, angle P is right here. I want to know, what is it congruent to? Now, since my lines right here and here, they don't say they're parallel, so I can't worry about corresponding or alternate interior, alternate exterior. I have to use just what I know is always congruent, which are vertical angles, so I should have an R here. Okay, so then the last one, number 14, true or false, is C congruent to D. So C and D, are they congruent? Well, they're a linear pair, so they're not congruent, they're supplementary. Okay? Look on the back side of that page. Number 15, angle ABC and DEF are supplementary. That means if I add these two together, they're going to equal 180. Okay? DEF, this angle here, is 3 times the smaller angle. So whatever this is, I don't know what it is, but this one is 3 times that. Well, look, I can see my equation right here. X plus 3x equals 180. So 4x equals 180. And that means that x equals 45. Be very careful because you have to go back and look, what is the question asking me for? It says to find the measure of angle DEF. Well, I didn't do that. I found x, right? So I still need to find DEF, which is 3x. So that's 3 times 45. So angle DEF is really 135. So don't stop at x. Keep going if you have to. All right, number 16. WSR and VSW are complementary. So WSR, this angle here, and VSW are complementary. That means if I add them together, they equal 90, right? Complementary 90. Okay? WSR is 4 times VSW. So this one, WSR is 4 times VSW, which I don't know what it is, so I'll call it X. Well, look, I can see my equation, right? X plus 4x equals 90. So 5x equals 90. Divide both sides by 5 and x equals 18. But then pay attention to what it's asking me for. It says find VSW. VSW, that is that small angle that we did call x, which means 18 is my correct answer. Number 7. Okay. Number 17, use the diagram below to answer the following questions. Which pair of angles appear to be complementary? Remember, complementary means 90, so I'm looking for angles that when I put them together, they look like they will make 90. So that would be angle 3 and 4. Which angles appear to be vertical? Those are across from each other when 2 lines intersect, so that would be 1 and 4. And then which pair of angles form a linear pair? Those are 2 angles that make a line. Just 2 angles. You can't use the top 3 because it has to be just 2. So that would be 1 and 5. Number 18. In the accompanying diagram, line AB and line CD intersect at E. If the measure of angle AEC is 4x minus 40, and BED equals x plus 50, find the number of degrees in AEC. So I need to find x. I know those 2 angles are vertical, which means my 4x minus 40 is equal to my x plus 50. I don't have any like terms on either side, so that means the first thing I need to do is I need to start moving from one side to the other. So I'm going to move my x over first. So these x's cancel out, and I'm left with 3x minus 40 equal 50. So then I'm going to add 40 to both sides because remember we're doing the opposite. And that gives me 3, these cancel out, so I just have 3x equals 90. Divide by 3 and x equals 30. And then we want to make sure that we look and see what the question was actually asking me. It wants to know how big is AEC. AEC is the 4x minus 40. So I'm not quite done yet. I have to do 4 times x minus 40. X is 30. So 4 times 30 is 120. 120 minus 40 is 80. Okay, and then you can also check if you plug it in here, 30 plus 50, that's also going to give me 80 because these two angles are supposed to be the same. Number 19. The accompanying diagram shows intersecting lines L and M. Solve for the value of x. So this is just like the last one, but I just need to find x. I don't have to plug it back in. So since they're vertical angles, I know these two will be equal. 7x plus 16 is going to equal 3x plus 48. I don't have any like terms, so I need to just start by moving things back and forth across my picture. I'm going to slide this up a little bit so I have a little more room to work with. Okay, so first thing I'm going to do is move my x's to the same side. So I'm going to subtract 3x on both sides so it cancels out on the right-hand side. And 7 minus 3 is 4x plus 16 equals 48. Then I need to move the 16 to the other side, so I'll subtract it. When I subtract 16, I get 4x equals 32. Divide by 4 on both sides, and x equals 8. And remember, it said just find x, so I am done right there. Okay? All right, identify which of the following statements are the converse, inverse, and contrapositive. So what I like to do on these problems is I underline my hypothesis in one color, and then everywhere I see the x and the 12, I use that same exact color. And you can either underline or you can use a highlighter, or if you're using just one color, you do a single underline one place, and then you can do a double underline over your conclusion or under your conclusion. So x minus 1 equals 11, x minus 1 equals 11, x minus 1 equals 11, x minus 1 equals 11. Because then what you can do is you can look and you can see what has happened in your figure. I can see I started on this one here, red and then blue on my original one. So when I look at the second one, it's still red and then blue. The difference comes in on this one because I see the not equal to. So this one, my keyword here is not. If I look at the second one, I can see that I have blue first and then red instead of how I originally had it red and then blue. So this one, my red and my blue have been switched. Okay, and then on the last one, same thing, it starts blue first, so that means I've been switched here as well. But if I look, I also have the not equal to, so this also has not. Okay? So then when I look back up at the top, I'm trying to decide are they the converse, the inverse, or the contrapositive. So I need to remember my keywords. My keyword for converse is switch. So I need to look and see where is it that I did nothing but switch. That says switch. It doesn't look like it. That would be right here, so that makes the second one the converse. Okay, and then my keyword for inverse is not, so I want to look and see where did I just use not, and that would be the first one, so that's my inverse. All right, and then the last one, the keyword for contrapositive is both. So when I look here, I can see I switched it and I used not. So that's both, making the last one my contrapositive. Okay. All right, the next video will be the second half of part 1 review.